frameworks, since that's sort of the prototyping thing we're going to be focusing on in this one. And I figured since Open Framework sits on top of C++ and you're going to need to know a few bits and pieces about C++, and neither of you are super experienced at C++, we'd start with some C++ programming basics. So unfortunately C++, like when I say C++, I mean the additional stuff on top of C. So the additional stuff on top of everything we looked at on Wednesday, which you could probably teach an entire course on. So I'm just very quickly going to go through some of the basic stuff which you're likely to encounter when working with open frameworks. So the first thing to look at, I know we looked at classes on Wednesday, but we'll look at them specifically, how C handles them, and we'll also look at structs because, I mean, they're pretty much treated the same way as classes in C++. And we'll also look at namespaces because I know I touched on that on Wednesday and didn't really sort of explain it too much further because I didn't have time. Right, so a struct is basically a collection of related data. So you guys have done OO programming before, so you should know probably more or less about structs and classes and stuff. In C, from memory, and someone will probably correct me on this, but I'm pretty sure in C, a struct is basically a class. Like, it doesn't actually treat them any differently. So typically, you should treat your struct as a sort of a collection of data. So in here, we've got a person which has a first name, a last name, and an age. If you can, with structs, you can add constructors and destructors and methods and all that sort of stuff. But if you're starting to do that, you should probably rethink how you're building your program because that probably sounds more like a class than a struct. But here's a basic example of how you do it on C on the side. So you basically struct and then you give the name of the struct and then all the properties that it has, so first name, last name, age, and then to create it down the bottom you see we got person, so the struct name, lecturer, and then you can just assign all the information to it like that. One thing to remember is that semicolon at the end of struct, because I always forget it, and then the compiler always complains that it's missing one. Right, so classes, as I said, they're pretty much identical to structs in C. It's just a slightly better way of encapsulating objects, so data and methods and stuff, and obviously you have constructors and destructors. So on this one, we've used the same example as before, except now when we create a person, we define the first name, last name, and age. We have a destructor. In this case, we don't really need to do anything in the destructor because we're not allocating any memory or anything like that. Don't need to clean anything up. And in this case, the person also has a method called lecture, which prints out blah, blah, blah 10,000 times. So this is how you construct a new class. So person lecturer, that's me, and then lecturer, and if you run this code, basically it just prints out blah 10,000 times. So the cool thing, well, one of the nice things about classes in C++ is you can actually split up their definition across multiple files to make it easier to read. So what we've actually got here on the left is we've actually got the same declaration or definition of person here, except we'll split it into two pieces. So we've got the person.h, which is basically the interface. So if you look at the .h file, you can sort of look at it and get a rough idea of probably like a black box of what it's going to do. So you have a person and, it takes first name, last name, and age. You have a destructor there. You have some method called lecture. You have a first name, last name, and an age. But we don't actually specify how any of these functions work in the .h file, instead of it all being quite complicated and maybe exposing how these functions work. What we can actually do is we can hide the implementation within another file. So here we have person.cpp, and you see up here it includes person.h, so it basically gets the prototype from here, and then we put the implementation here. So we have the implementation for the constructor, the implementation for the destructor, and the implementation for the lecture method. So, you might be wondering when that's useful because, if you're writing your own code, then you probably don't really care who knows how it works. One of the things you can do in C and Java, I guess, as well, you can create library files. And when you create a library file, basically you just get an executable .lib file and you give the person the .h file. So if you have some super secret algorithm running, you can put it in the .cpp file, and then when you compile it into a library, it basically turns it into machine code, and then you just give the person the library machine code in the .h file, so they don't actually know how your methods work. They can see how to call them, but they don't actually know what's going on internally, which is kind of nice. You can keep it of a secret. And then, again, we've got this main.cpp, which is calling it. And you'll see here, we actually just include person.h. We don't need to include person.cpp because the compiler's smart enough to figure out where the actual implementation of the code is. And one last thing to note, in C++, you have these things known as compiler flags. So here's one up here, this pragma one. And pragma once basically means only include this file once. No matter how many things are including it, don't keep on recompiling it, because otherwise what will happen is you'll end up with multiple definitions and stuff like that. So if you start having problems with multiple definitions, try throwing one of these pragma onces at the top of any .h files you're using, and hopefully it'll resolve it. Yeah. So there are other ways of doing it as well. You can use if-def, or rather if-ndef and blah, blah, blah. But yeah, as Timo said, the if-ndef will be used to support pragma, yeah. So not all the pragma compiler definitions work on all compilers, but certainly they work in Visual Studio and probably most of the main ones, as Timo was saying. So before we go from classes to namespace, actually just one other thing I meant to mention here. So this is the format C uses for basically defining the method of a class. So you have the name of the class, 2 colons, and then the method name, so the constructor, the destructor. For the constructor and destructor, they don't have return types, so if you put void or anything before here, it'll complain. But when you have actual methods, you need to say void, class name, : method name. It's a little bit weird, but yeah, you just have to live with it, really. Right, so before we move into namespaces, I just want to shortly digress about templates, because this will be... templates are incredibly powerful, but I still to this day find them quite confusing, but you're going to need to learn at least how to use them, if not create them. So what templates are you guys ever come across templates? Generic programming? Yeah, that sort of stuff. Okay, so templates are basically allow you to do compile-type generation of code, and Wikipedia defines them as to be specified later types. So the idea is if you have some function or something which operates on data, say it adds 2 numbers together, like you saw in Wednesday's lecture, we can overload the function, so we can create a function which adds 2 ints together, adds 2 floats together, adds 2 whatever together. What templates allow you to do is basically write one piece of function, and you just say, I'm not going to tell you what the type is. You can figure that out when you're compiling the library. So instead of creating something which adds 2 things together and creating it for every possible data type, you just create one template and just say, add these 2 data types together. You figure out what data types are going to need when you compile it. So it's quite cool. It's really powerful because it allows you to write one piece of code to handle multiple data types, and which is good because things like, and we'll see in the standard library, for example, the vector class, which is basically an array. It allows you to add things, remove things, iterate across it. There's no way that they could have written the vector data type to support every conceivable object which could ever be created. So instead they use templates, and that way you can actually create a vector which will hold a data type that you've made yourself, and it works fine. So it can be done at a class or function level. So in fact, you can have classes which are data types and stuff. So this is the vector example I was talking about in the standard library. So you see up here we have standard vector, and this is a class level template. So we basically create a new vector, and we say it's going to be a vector which contains ints. So in templates in C, you use these angled brackets to basically say this is the data type we want to use. And what we do is what happens is when we compile this, the compiler will come through and see standard vector int. So it'll actually create a vector which takes type int. So it basically goes through and replaces every time it sees the template with int. So that then we can do this. So you can see here we can create a vector of ints and push some ints into it, one of floats, put some floats in it. We can create one with strings, put strings in it. If you created your own classes, so the person one we saw before, you can standard vector with your class name, and you can push your own classes into it. So the reason I wanted to highlight that is because we'll see some templates in a minute, and you'll deal with them a lot if you're using the standard library. Right, anyway, back to namespaces. So a namespace It has the same sort of look as a class. So you saw before, when we're dealing with classes, we use these double colon things, and it basically defines here's a class method. Namespaces do a similar sort of thing, but it's for more loosely related concepts. So basically, if you're doing some library or something and you want to say, okay, all of this belongs to this library, you can encapsulate them all within a namespace. So the best example is the C++ standard namespace. So C++ standard namespace basically encapsulates a lot of the classes and stuff that you find in Java. So all your things for input, output, arrays, strings, all that sort of stuff are in the C standard namespace under the name std. And if you want, you can go to this website and there's a reference of all the, in fact, I'll see if I can go to it. I don't know if it covers all of it, but it certainly covers a lot of what's in the standard name things. So there's a C library here, and then there's miscellaneous headers for all sorts of stuff. So you can go, if you want to deal with strings, you can go and have a look at string and it'll tell you the functions and stuff which are in there. Right, so here's an example of how to use the standard namespace. So here we've included string, which obviously deals with string handling, IO stream, which provides input and output streams. So this here, cout and indel for end line, vector, which we've seen before, and map, which is kind of a cool one as well. So you see down here, every time we're accessing anything within the standard namespace, we need to start it with std : and it's basically saying, look inside the standard namespace and use this class string. So my string, this cout is a stream that we can write to. So cout is console out, and endl is end line. Vectors we just saw before, and standard map's another one I just wanted to briefly highlight. Where basically it's again a templated function, and it basically maps one item to another item. So down here I just use this example that I found on the net of basically colors and how women define them and how men define them. So, you know, maroon, plum, eggplant, grape, orchid, and lavender are pretty much purple for all intents and purposes. So in this case, we're basically setting up this map, and we're saying in the woman to man color map, the color maraschino points to red. So if you then went printf woman, man, color map, maraschino, it would print out red. So it's basically, if you want to communicate to guys about colors, you could use this color map to do so. So one other thing you see here, as I said before, if we're ever accessing things in the standard namespace, we have to start with std, which can be a little bit tedious, especially when you see down here a map. We've got standard map, standard string, and it can get worse than that. So what you can actually do is you can actually use this hash using thing. Sorry, it's not hash using. Is it hash using? I can't remember if there's a hash beforehand. We'll have a look at it soon. But anyway, you can use this using namespace thing, and basically it just says for all these things, check to see if they're in the standard namespace beforehand. Right, so that covers more or less when to use each one. Calling conventions. The only other thing is nesting. So structs, classes, namespaces can all be nested. Certainly structs can contain structs. Classes can contain classes and structs. Namespaces can contain namespaces, classes, and structs. So you can nest these in, and then like you might have like standard, or so if you're using the standard library, you might have standard vector, and then something inside vector, and then a struct inside vector, and so it'll be standard : vector : next class : struct : so on and so forth. So they can all nest within each other and string together. Right, so that's a bit of time. Oh, not too bad. So that's sort of looking over those. So another thing, pointers. You guys familiar with pointers?
Yes.
Okay.
I learned them, but I can't remember.
Fair enough. Again, it's something which you're not going to be able to avoid working with C++. It's something which can be incredibly powerful, but also a huge pain if something goes wrong with them, because it's quite hard to debug. But as I said, you're going to run into them, so we'll briefly cover them. So a pointer points to address in memory. Pretty straightforward. So here we have int x equals 6. So we basically get a piece of memory and we put the number 6 in there and we say, okay, x is that. Now here we use the referencing operator, so this AND, which basically says, allocate a piece of memory and point that to wherever x is. and in this case allocate it to y. So the star here means that y is a pointer, and the ampersand means we're getting the address of x. So basically what we're going to do is we're going to create a variable y, some space in memory, and inside that space it's going to contain a memory address which actually points to whereabouts in memory x sits. So if you try and dereference y, or like print out y as it is rather, you'll just get a bunch of garbage, but basically that's a position in the memory of the program for where the variable x sits at. And then we can dereference it again. So if we use this star thing, star operator, we can actually say, okay, follow back down the pointer and see what's here. So you'll see here int z equals what y is pointing at. So it's not actually going to point to x again. It's going to find out what the value of x is and then copy it into z. It's a very useless example, this one, but it sort of just shows how you can go from one to the other. Yeah, so as far as non-primitive data types, so here, when I say primitive, I'm talking about ints, floats, chars, bools, all those sorts of things. When we're dealing with non-primitive data types, so structs, classes, objects, all that sort of stuff, we actually access its methods using the, I don't know, do you know if this symbol has a name, the arrow? Yeah, I just call it the arrow accessor. It's probably got one, but I don't know what it is. Instead of the dot accessor. So here we have the same person structure as we had before. We're creating two people, P1, which is a person, and P2, which is a pointer to a person. If we want to access the P1's first name, we use P1 dot because it's just an ordinary person. If we want to access P2's name, we use P2 and then the arrow accessor, and that basically says P2's a pointer, so follow that pointer and then get the first name, which is there. This code won't actually work, and we'll come back to why it won't work in a minute. As far as why you might want to use them, pointers basically allow you to pass a reference to an object into a function, which allows the function to modify the object directly. So I've got a couple of little chunks or snippets of source code down here. So let's say we have some variable x which we define in the main function, and we want to have a function which modifies it somehow. So we create x here, and we printf the value, so we set it to 0, we printf, and we get 0. And then we call modify x, so we come up to this function, and we add 1 to x, but what we're actually doing is we are basically copying the value of this x into this x, and then we add 1 to the value of this x. So this x down here, or here, never actually gets modified. We're only modifying this function's x. I probably could have used different variables to make it slightly less confusing, but essentially we have two x's. There's one in this scope and there's one in this scope. So when we add 1 here, we're only modifying this one, not this one. So you see when we print x after, it's still equal to 0. So if we have this modify x function, we're not actually modifying this x here, we're modifying this one here. So what we can do instead is we can use a pointer to it. So here we create a value, an integer y, set that to 0, print it out before it's 0. And then what we're going to do is we're going to call this modify y ref function. The ref is, you can name this whatever it wants, the ref is just there to illustrate. But what we're going to do is we're going to pass in the reference or a pointer to it. So we use this ampersand to get a pointer and we pass it in here. And you see here we've got int star y, which basically means we're getting a pointer to an integer and storing it in y. And what we do here is we basically, we're accessing the value of y by using the star, adding 1 to it and returning, and then we print it out. So this time, we're not actually creating and copying the value of y, we're copying in the pointer to it. So then when we access that memory location, add 1 to it, we're actually modifying this one. And if you run this code, you'll see y before is 0 and y after is 1. Not so useful if you're just dealing with integers, but it becomes more useful when you're dealing with large data types, so say people, this person struct. So again, we have created a lecturer, and this time we have an increment age function, so a birthday essentially. If we just pass in the actual object itself and try and increment the age, we get the same problem here. So basically this person P up here is a copy of this person P. It's not the same object. So when we try and increment the age, it only increments this person P's, not lecturer's age down here. So we'll see 29, 29. However, if we pass in a pointer to the lecturer and add 1 to that person's age, then you'll see when we come back out of this loop, the age is actually incremented by 1.
So is that used basically for optimization? So like you're not duplicating your data. So you've got
Yeah, so it is slightly faster to call a function with a pointer rather than the other way, because otherwise it's got to allocate some memory. As far as how much faster, it's probably nothing really, but it's more so so what we could do here is we could have a function which perhaps returns a thing, but if you're modifying multiple pieces of data, you can only have one return. So yeah, it basically allows us to modify the actual original object rather than copying the object and modifying that. So, in these examples, we're only modifying one thing, but if we're changing a whole bunch of pieces of information, the best you could do is return another person. But say you have a function which takes 2 items and modifies them both. Really, the only sort of way you could do it is by passing pointers and then modifying the pointers. Yeah. So yeah, I mean, these examples are all very basic, just to give you guys the idea, but you'll come across this a lot in open frameworks or anything. Like you'll be passing pointers to objects rather than the actual objects themselves. So I said on this slide, this example wouldn't work. That's because when we create a pointer, it points to nothing by default, and unless we allocate some memory to it, it'll give us errors if we try and use it. So this is the same example as before, and this is what happens if you try and run it. So here, we create a person P1, and when we do this, it allocates a piece of memory and gives it to us. Here it basically just creates a pointer, and the pointer is not actually pointing to anything. It's just like a memory, or a little piece of data which has an address in memory, which who knows where it's pointing. But when we basically try and dereference it, so we try and find out what it's pointing at, it's obviously not a person, and we get this error here, runtime check failure 3. The variable P2, so this one here, is being used without being initialized. So we have a pointer, but it's not initialized, doesn't point to anything. So what we can do is we can create pointers and allocate memory to them. And the reason you do this is objects don't get deleted when they fall out of scope. So if you want an object which is going to last, even when the method which creates it exits or whatever, you can create these pointers, allocate some memory to them, and then it's your responsibility to actually delete them. So here is the same example, and this time we're using the new keyword, which basically creates a piece of memory, sticks a person in it, and then we point P2 to that piece of memory we've just created. So now we can modify this, and the only thing you got to remember is when you're done with it, you have to delete it, otherwise it will hang around and you'll basically eventually chew up all the memory and your program will crash. Right, so that is a very basic rundown of the things which you are most likely to come across in C++ when working with open frameworks. So let's go to open frameworks. So we covered a few of these slides on Wednesday, but we'll just quickly go over them again. So open frameworks, open source toolkit, written in C++. You have to use your own IDE, multi-platform. And it has libraries which support working with media, working with hardware and communication, so network, Ethernet, Bluetooth, all that sort of stuff. Why you would use it instead of processing, so because it's written in C and it compiles down to machine code, it's faster. Java is getting better, but it's still interpreted code, so it's never going to quite be as fast as raw machine code. You have accessibility to low-level information. So with pointers and stuff like that, you can do some pretty cool stuff. However, you're asking for trouble if you do that. So maybe when you feel comfortable with pointers, you can start doing stuff like that. So you have a really good debugger. The processing IDE by default doesn't have a debugger. If you use Visual Studio or whatever, it does have a debugger to begin with, so that's really good. It's written in C++, so that is either a strength or a weakness depending on how you feel about it. And open frameworks is all under GitHub and everything, so you can use all sorts of version controls. You could use version control in processing as well, but you sort of have to set it up yourself. So you saw pros and cons. Right, so I think that's the last slide we stopped on. So this is basically how open frameworks sort of fits together. So when we create a program, we have our main.cpp, which you generally don't touch. That's what Open Frameworks creates for you, and it'll basically get everything set up and start running your program. What you're responsible for writing is testapp.cpp and testapp.h. So the .h file, as I said before, is a header. You put definitions of stuff in there. And the CPP is the implementation, so that's basically where you define what the code can do. So this is pretty standard C stuff here. This is where Open Frameworks comes in. So Open Frameworks provides this middleware layer basically, where it has, so there's all these base libraries down here which you can use in C++ or C. So OpenGL, Glut, FreeImage, FreeType, all sorts of stuff. And Open Frameworks basically provides wrappers around each of these to make them easier to use, so you don't have to worry about initializing them or dealing with memory management or any of those sorts of things, which if you're using one of these libraries for the first time, you'd probably need to read the documentation to try and figure out how to get it to run. So Open Frameworks installation. So what I might do here is actually install it. So hold on, first I'll go to the Open Frameworks website. Oops. So here's the Open Framework site, which we did look at last time as well, because I remember now that I still don't have Flash installed on here. But you can go to the download webpage and you can grab Open Frameworks for code blocks. If you want to use that UI or Visual Studio 2010, or if you're using OS X or Linux or whatever, you can grab them from there. Again, I did this like start of this week. Here's the file, and basically it's just a zip file that you unzip, and it's got a bunch of stuff in it. And when you get here, you're on the project generator. I think I briefly showed you this as well. And the project generator runs, and you put in the name of they call them sketches, or the project you want to create. You specify where you want it to put it, which platforms you want it to run on, which add-ons you want to use, and when you're done, you just hit generate, and it generates it, which is nice. And then that's going to be in apps, my apps, mhit01. And we have this mhit01 solution we can open up. And always ask me if I want to open it. Sure, there's probably a way to turn that off, but never mind. So you'll see these are the three files we were talking about before. So we have main.cpp, which is created for us by Open Frameworks. You don't really need to do anything in here. You could probably, if there was some special initialization or whatever you wanted to do, you could change it, but in this case, you're probably best off leaving it alone. But basically, it sets up OpenGL, creates a window, and starts running your app. So this is our app here, and we'll start looking at the .h file so you can get a rough idea of what it looks like. So we have this test app, which is ours, and it has three functions, which are basically stuff which you might want to fill out. So you have setup, which gets run before anything starts running. So it's a setup function, so you can put code in there if you need to initialize anything or set anything up. We have an update function, which gets called, I don't know, every time it updates or something. I'm not sure how. Just before draw, yeah. And draw gets called every time the screen needs to be refreshed or something on one of the elements on the your program needs to be updated. And then you've got a bunch of event-driven things down here as well. So you have key pressed, key released, mouse moved, mouse dragged, mouse pressed, mouse released, window resized, drag event, and got message. So, you know, obviously these are for input. So key pressed is when you push key down, release is when you let it go, mouse moved is when it moves over the window, dragged is when you move over the window with the button down, pressed is when you push a button, release is when you let go of the button, windows resized when you resize the window, and I haven't looked into drag event, but I'm guessing it's when you're dragging objects around on the GUI, or perhaps dragging the window itself. And then if we look into test-app.cpp, you see we have the implementation of all these functions, and they're all empty because that's where you start writing your code. Right, so that's basically a brief look at how it begins. So what we'll look at now is the add-ons. So one of the, as I said before, the main strength of Open Framework is it's community-driven, and lots of people contribute their own add-ons, which basically wrap around these libraries. So you see here up the top, we have libraries for animation, bridges, computer vision, graphics, GUI, blah, 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 blah. And for each one of these, you see there is heaps and heaps and heaps and heaps and heaps and heaps of libraries. And then there's some other stuff down the bottom. uncategorized ones if you're really looking for something. So say you want to do some GUI-based stuff, you can come down to GUI, and there are 78 different GUIs you can choose to use. So it's kind of cool. It's kind of overwhelming as well. But yeah, if you go through and read through them, you can download them, and some of them have documentation, some of them unfortunately don't. What we'll look at to begin with, though, is OFX UI, because that's the UI one that we're going to start working with. So we have OFX UI by this guy, and it's user interface library add-on for open frameworks. So we can click on this one, and here we have the README. So it's add-on for open frameworks, easily allows for creation of user interfaces. Takes care of widget layouts, spacing, font loading, saving, loading settings, widget callbacks. Can be easily customized. Contains a collection of minimally designed user interface. Blah 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 blah. Got a bunch of information. What's inspired him, what it's based on, and a brief tutorial on how to do stuff with it, basically. So to use these add-ons, what we do is we download them. Hooray, it's actually going to download. So we can download it, and then when we open it up here, you'll see we've got, again, a bunch of stuff, a bunch of folders and stuff. So what we do, now there may be a better way of doing this, but this is the way I have been doing it. So we go into here, and in fact, if I just jump back to the slide here. So in Open Frameworks, we have the add-ons, which add-ons folder, this is within the Open Frameworks folder. Add-ons folder, which contains libraries from the user community, must be explicitly included with programs when using them. So, okay, we just downloaded a new add-on. We want to include it. So we open up add-ons, and we grab, whoops, where's he going? We grab this, and we just drag it in there. And I will close this one now because I don't need it. And I'm not sure whether this is whether there's a better way of doing this, but I've found if you rename them to just the OFX part, then the project generator will actually be able to pick them up. So you'll see now when I load the project generator, so we're creating a new sketch. Oops, HITD601. And now if we go to add-ons, you'll see we've got a new one over here, OFX UI, that we can include, which is the user interface library that we just added. Generate project, creates our project. Where are we? Apps. My apps, HITD601. And now in this one, we can start using that GUI stuff. So let me just have a quick look. Okay, so we'll come back to that in a minute. So yeah, anyway, we just looked at the add-ons folder where we add libraries from user community. Apps is obviously where our programs get created, because every time we use the project generator, it creates them. And libs is where the core libraries of open frameworks are stored. And this is just another look. So open frameworks, then you have apps, examples, and add-ons, and libs. And that's more or less the same sort of thing again. So apps, then you have the workspace, then your examples, and so on and so forth. And all of these are for in macOS, but the structure is fairly similar on Windows. So within your project folder, there's a bunch of different folders. So you have the /src, which is source, so this will be the source code for your project. And then in the bin, it's where your executable will be created. And then in data, you have all the data which your application may require. So we basically looked at this already. Main sets up window size and OpenGL context. Test app contains a bunch of functions that you have to fill out. And test app is where you actually do the implementation. So this is typically what you do. In setup, you load your assets, initialize any values, and initialize add-ons or components. In update, you perform any calculations and increment video frames, and then draw is where you do all your rendering style stuff. And this is the last slide of this lecture. So we're going to actually look into some examples of the OFX UI library. So we've already looked at the README. Unfortunately, OFX UI, as far as I can tell, has no documentation, which is kind of a pain. But it does have lots of examples, and the examples are fairly straightforward to understand. And then we'll come back and look at code UIs versus WYSIWYG. Right, so the first thing to do, if we come back to add-ons and we go into OFX UI, you see we've got all of these examples in here. So the first thing we're going to do is we're going to jump into, actually no, we won't do that. We'll go back to the mHIT one I just put together, still got down here. And in this one here, you see in the README at the bottom it's got a tutorial, which is actually fairly legible, which talks about how to set it up in a bunch of other stuff, a bunch in macOS, but we're going to do it in Windows. So the things are fairly similar. Actually, I just need to delete that. The way to set it up is fairly similar on PC, but we have Project Generator, so we don't have to create the folder ourselves. Right. Oops. Right, so we'll create this one. Actually, we'll do this my OFX UI. And we need to add the OFX UI. And if you actually see in here, somewhere it says, all right, add OFX XML settings to the add-ons folder inside your OFX code project. So in this case, we're not going to do that because on macOS you don't have this project generator. But what we can do instead is we can choose OFX XML settings, and when it generates the project, it'll use it. So OFX UI uses XML to basically save the state of the GUI when you're exiting the code, which is kind of nice. Like you can quickly prototype something and give people a bunch of options, and then when they use the program and do some stuff, and then when they exit and they come back out, it loads all the settings they had, which is kind of nice. It saves trying to do it yourself. But you have to either include OFX XML settings, or it does say somewhere in here that you can, if you define some variable, it won't save the things afterwards, so you don't have to use it. But anyway, so we'll jump into this now, and let's throw this one over here, throw this one over here, and we will work through the tutorial. So the next thing we have to do, import some resources that OFX UI, so we're looking at number 6 now, we'll use into the data folder of the project you're working on. The easiest way to do this is go to one of the examples in the OFX UI add-on folder and copy and paste the bin data GUI folder into project's data folder. Bin data. Right, so basically what we need to do is we need to go back to here and grab one of the examples. So we'll just start with a simple example, bin data, and they have GUI. So this is basically like just some GUI settings and the font that they use. Why they're using their own font, I'm not really sure. We could just use one of the Windows default ones or whatever, and it will be fine. But regardless, so we're going to bin data, and we're just going to copy that GUI folder in there. So we have GUI settings and the font. The last step is critical, so that OFX UI can find proper resources for rendering fonts. So there you go. Right, so now we're actually going to start doing a bit of development. So the first thing we do is we go to testapp.h. So this is our interface file, and we're going to include ofxui.h. Then in our testapp.h file, we're going to create a new OFX UI canvas, taking OFX UI canvas GUI. So as I said before, this is a pointer to an object, so this is why we're looking at pointers. Within the testapp class, in addition, create the following 2 functions. So we're going to add another 2 functions in addition to the original ones, exit and GUI event. Right, so now we swap back to here, and we're going to basically create the implementations of those functions we just used. So testapp and the double colon thing, exit. And we're not going to put any code in it for the moment. Testapp GUI event, and that takes an OFX UI event args. And we're not going to put any code into that either. Right, so now we're up to step 10. Within the setup function, we're going to initialize the GUI object and add widgets to it. One way to do that is, so the first thing, and this is what we looked at before with memory management, we have a pointer to an OFX UI canvas object, and now we're actually going to allocate some data and set it to point at that. So we're going to set up a new OFX UI canvas, And we can go through the function prototypes. So number one, default width, default height. So we can actually create one default. We can create one with X, the X position, the Y position, the width and the height, and all that sort of stuff. So they've chosen to use that one. So 00 by 320 by 320. So that's going to be the position and the size of our GUI within the window which is created for us. And then because as I said before, when we create memory, we should make sure that we delete it. So in this case, if we want to save our GUI, we can go save settings and we tell it where we want to save the settings to, XML. And this is where we clean up our memory, so we're going to delete the GUI. Right, so if we run this now, a little bit of luck. So here's our window that Open Frameworks has created for us, and this little grey rectangle here is the GUI, OFX GUI we've just set up. So you see it's not particularly interesting, there's absolutely nothing in it at the moment. So let's go back and throw some things in it. So we're going to go GUI and add widget down. So in this case I'm just going to copy straight out of there, but basically in OFX UI, all the user interface elements are called widgets, and you add them to a GUI using these add widget, and you can add them down, which means it'll just add one after the other. You can add them to the right, to the left. You can specify where you want them by saying south of, and tell it another widget you want it to add, like where you want it in relation to other widgets and all sorts of stuff. But we'll have a quick look at that later. So on the first line here, what we're doing is we're creating a new label, which reads OFX UI tutorial, and we're going to write that in large font. Then we're going to add widget down. So this will be below the label. We're going to create a new slider, and somewhere in here we'll see the function prototype. So here we go, width and height and minimum value and maximum value and beginning value and the name, so background value. And now if we want our widgets to actually respond when we do stuff with them, we have to add a listener. So GUI, new GUI event. This basically says look in this class, and we're going to call test app GUI event. So this is basically we're creating a listener object. So we're saying anytime that new GUI event fires, we're going to tell it to call test app GUI event. So if you remember, test app GUI event was this function we created earlier, and anytime anything happens, it'll call this function down here, and we can decode what event has been called, what's happened, and deal with it appropriately. And GUI load settings. Again, if we want to save and load, we can basically save and load everything in the GUI using that bit of code there. Right, so if we run this now, you see we have OFX UI tutorial. So this is the label we just created, and our background slider, which goes from 00 to 255, and it started at 100. At the moment, it doesn't do anything, but if we go into our GUI event and basically put a little piece of code in there to actually say something's happened. So you see whenever we drag this, that GUI event's being called. So you saw it was called once before I even did anything. That's because the GUI event actually gets called when objects are created and destroyed as well. So when the slider was created, it called the GUI event, and every time I modify it, it gets called as well. Right, so that's not particularly useful. Let's actually make it do something. So what we can do now is, you see in here, when GUI event's called, this argument is passed in GUI event args e. So what we can do is we can check that. So we first say, get me the widget which was fired, and we get the name of that widget, and if it was background value, which hopefully is the same thing, I've called it up here. Yep, background value. So we're basically saying if the widget which had the event happen was background value, which is our slider, we're going to say, okay, we know the widget is actually a slider, so we're going to do this casting. So we know the widget in this case could be any widget. It could be a slider, it could be a button, it could be anything. So we check to make sure that it is the slider, and then we cast it to a slider. So now we can treat it as if it was a slider, and we can go OF background, which basically sets the background color of our window, set to slider.get scaled value. So get scaled value will basically return a number between I think 0 and 1, depending on its position on the slider. And if we run that now, you'll see when we change that, change the brightness and color of our background. Right, so there's a few more things in the tutorial. It adds a button to do full screen, but as it turns out, they've actually done the hard work for us. So if I go back to add-ons, OFX UI, you'll see if we scroll down here far enough, it's OFX UI tutorial. I'm not actually sure that I've opened the right one. Oh, no, I have. So yeah, if you go in there and, is it? Yeah, if you go in there and open it, this is basically what the completed tutorial will look like. I'll just give that a second to build. Okay. Right, it's unfortunate. Just try. Hold on. Most of the examples should run actually without that. I'm not sure. Let's just try this one quickly. Right, okay. So yeah, run the project VS 2010 solution. Right, so you see we've got the slider and button. However, there's no font here. Now, don't ask me why this is, but for some reason the paths in the OFX UI settings are wrong. So you see here, this is absolutely freaking out. Error font not allocated. So I've got a couple of minutes. So what I'll just do is I'll show you quickly how I debug this error. So we've got font not allocated. So what we do is we just quickly go font not allocated and search for where that occurs. And it was in drawstring. If you look at the error message, it basically says drawstring error, font not allocated, blah, blah, blah. So what we can do is, unfortunately, that error message doesn't really tell us much about what the problem is. And it comes up so much, it wipes out all the errors beforehand. So if we put a breakpoint there quickly, it'll stop the first time that function gets called, and then we can see what the beginning messages were. So we can see load font, invalid file name, C drive users, HITLab NZ desktop, blah, 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 add-ons, UFI, example, data, GUI. So if we look in here, we go example OFX UI tutorial. Wow, if we look at the full path, C drive users, HITLab NZ desktop, the OF folder, add-ons, OFX UI, example, and then it says data. However, as we saw before, it's actually bin data. So you see we're missing the thing bin here. And this is the case for all of the OFX UI examples for some reason. So what we can do is we can go in here, and if we look into the properties of our project, you see the output directory is where it's going to put the executable. So in this case, it's /bin, and debugging is where, and in debugging, the working directory is where it actually works from. So it's actually working from the project directory, which is where this, this solution is. So it's actually starting from in here, and then it's looking in data UI. But it's actually in bin data UI, so what we can do is we can just change this from project dir to out dir, where out dir is basically this output directory here. And if we run that again, now you can see we have the text. So that's just because it couldn't find the text file that it was supposed to load. So that's the tutorial. It's worth having a look. We're running out of time a wee bit, so it's worth having a look through that. And in fact, if you follow through the tutorial here, you'll end up with that exact same code. So what we'll do now is we'll just look at a couple more examples. I'm probably going to have to do this for all of them. So if you remember before, the directory that it's running from, so the working directory is wrong. So just to save our time, just change that now. So this one now we're looking at is simple example. So just scroll over here and quickly open this up. You'll see it's got some, well, okay, so this is the simple example here. And if you look through the code, it's got all your typical things, creates a new UI, adds some widgets, so some labels, some spaces, sliders, all that sort of stuff. And then it has, so they actually have filled out some stuff in the draw method. So in the draw method, it's basically creating this, believe it or not, it's actually a circle. And it's just doing some other stuff. So it's a pretty simple example to go through. The important things are obviously the setup, the draw function, which draws the circle in the background, and the GUI event, which handles all the events, and everything else is fairly straightforward. So if we just look at this one here, so we can change the background color of the window, we can change the color of the circle, and it's alpha blending. We can change the radius, just make that something a bit more visible, and we can change the resolution, which basically means how many lines a circle. So at 3 it's a triangle, and then it just gets more circular. And then they also have this slider control, or this, I can't remember what they call it, widget down, a 2i pad, a 2D UI, a UD2i pad, 2D pad, sorry, which basically when you click on it, it just gives you the X and Y position, and then they just translate the circle by that, and you can turn the draw fill on and off and stuff like that. So it's a pretty simple example. And just look at one more quickly, because we only have 5 minutes left. And first thing we'll do is we'll go in and change the working directory so that it's running from the right directory, so that it can find the fonts and all the graphics and stuff. Now this one's a bit more complicated. This is OFX UI all widgets, but it's a good one to look at because the code's a bit more complicated, but it actually features all the widgets. So you can look on here and see all the widgets which are provided to you. So you have sliders, or horizontal sliders, you have vertical sliders, you have radio buttons, so buttons where you can only select one. You can draw a background grid, or buttons, so a button which just flicks on and off, and a toggle, so stays on, stays off. A range slider, which goes between two ranges, so you can set the minimum range, the maximum range. It's 2D pad down there. Unfortunately, the resolution's too low to see the rest of it. You have text input, some text input things, a waveform display, spectrum display, images, frames per second, all sorts of buttons, matrices, image buttons, image toggles, so buttons and toggles, rotary sliders, drop-down lists, by-label sliders, a single or label with a slider with a label in it and a label off the outside, circle sliders, frames per second sliders, image sampler. So heaps and heaps of different UI elements on there. And if you go in here, you can go through and look at how they've created them all. So in that one you saw they basically had 4 GUIs side by side. So you pick which one, which feature you like, and they've actually set up all their GUIs. They've actually set up all their GUIs in separate functions. Oh. There we go. So the first GUI, so the leftmost one, is all set up in here. So to make the code a little bit easier, but it's worth sort of having a look through how they handle some of these and stuff like that. And on that note, here are your assignments for this week. Yeah. So this week's assignment is designed to give you a bit more experience with open frameworks and creating GUIs and code. So download and install Open Frameworks and the UFX add-on, work through the examples, in particular tutorial, simple example, and all widgets are the ones we just looked at. and try and get an understanding. When you feel comfortable, have a try modifying it and see what you can do. So your actual assignment is to recreate. So last week you designed your own photo board. This week, because you guys are just getting the hang of the UIs, you are going to recreate the photo board as it is out there. So you don't have to worry about interactivity or anything like that. Just try and recreate it. It's a red background, photos and people's names and stuff on it in a grid. Don't worry about using putting everyone on there, because that's far too much work. But try and at least add the people who are lecturing this course. So Mark, Tom, Andreas, Christoph, and me. And if you go to hitlabnz.org and then go people, and then you see our names on there, and you can click on everyone's names, and you can steal people's photos off the web page. So it should be organized in a grid, the size of which will depend on the number of people you choose to use, but it should be at least 3 pictures wide by 2 people high. So there's 5 people, 5 lecturers, so you should have 3 on the top row, 2 on the bottom. You don't have to include the interaction, but I'd recommend at least having a look at how the buttons, and maybe sliders work. You have to do them in the tutorial anyway. If you wanted to, you could replace the name labels with buttons and add some interactivity. You obviously don't have to do that. It's up to you. All you have to do is recreate it. So I had a go at doing this. I figured I'd better make sure that it was not too much work. So I actually put my own one together yesterday. It took me about an hour. Most of that was trying to figure out how OFX UI works. So it should be quite achievable for you guys. And this is the sort of stuff that the final sort of product should look something like this. So nice red background, photos of people. Mine, I went a little bit further, so you can actually click on people, and then you get like their personal profile page. So Mark's the director of the HitLab, profile picture, and there's a back button, and you can go in. And the reason Andreas and Christoph look quite fat is because I've just scaled all the images to the same size, whereas they're not actually the same size. Andreas is taller and skinnier, so it gets squashed out. But yeah, so you should be looking to do something like this for your assignment. Create something like this. And if you want to throw in extra features, awesome. But at the very least, should have pictures and names and stuff on there. And maybe if you feel like you could try and add some interactivity like this. And that will be due next Friday. And at the moment, I don't have the website set up for uploading, but I'll do that on Monday. And if you just upload maybe a zip of the folder or something like that, so we can have a look at it. Otherwise that is that. Are there any questions?
Do you want commenting and stuff like that? Just for our life, it doesn't really matter.
Yeah, you don't have to. I mean, maybe if you want to just comment blocks. So, comment this puts on Mark's picture, and then you have 3 or 4 lines. Don't worry about commenting everything, but if you want to throw in like a little bit just to, But I'm certainly not going to mark you down if you don't have commenting at this stage. This is really just to give you guys a chance to play with open frameworks and get a bit of experience with OFX UI as well. Because next week we're going to start actually doing some useful stuff with it rather than just So any other questions? No. Is there anything which has come up which you guys would like a better look at come next week, or for the lectures next week, or? No, you happy? All right, cool. Well, if you think of anything which, and in doing the assignment or playing around with your tutorials, if there's anything you don't understand and you'd like me to clarify a wee bit, just let me know. All right. That's just finished.